what I mean here in a minute. But our goal in these first couple days, and you can tell if you just look at your note sheet, we're going to be doing some graphing. All right, so we're going to graph this thing. Now, for each of these problems, you are going to be responsible for finding 5 important things. So down here at the bottom, where you have a little bit of extra room on the note page, I want you to write down these 5 important things. We're going to find vertical asymptotes, and you can abbreviate this. So if I abbreviate, that means asymptote. So you can write VA, as long as you remember VA stands for vertical asymptotes. When we're talking about it, horizontal asymptotes, x-intercepts, y-intercept, and holes. Now, all of these things you have talked about with me in this class. Does anybody remember anything about any of those words? We're going to make a list of how to find them. Jacob? It's where we cross the x-axis, exactly. And I want you to think about this, kids. If I am crossing the x, like let's say on this point right here. Remember on the test you just took, didn't you label a bunch of those? Well, some of you didn't, even though I told you to. But if you did label them, wasn't it like 2, 0? Yeah. Or 3, 0? So the x-intercept is going to be something, 0, every time. So when I get ready to do my graph, and I just randomly put that one up there, when I get ready to do my graph, points on the x-axis are going to be important. Okay? You gotta remember any of the rest of the things. Well, what's a y-intercept then? A point on the y-axis. So this is going to be 0, something. So notice, because it's easy to get these confused, notice that if I am looking for an x-intercept, I let y be 0. But if I'm looking for a y-intercept, I let x be 0. So whichever intercept you're looking for, you let the other letter be 0.
The horizontal asymptotes, you define the highest power of axis.
Exactly. So I'm going to just say, I'm going to say box in highest power. So do you remember doing that, kids? Like, I'll just do this one. Do you remember going like this? And that meant that your horizontal asymptote was y equals 1. We did that. All right, good, good. Anybody remember anything about vertical asymptotes or holes? When do holes happen? Not very many problems have holes. When do they happen?
Radical?
No.
So no.
When something cancels. You have to have something cancel. So when I look at the problem I'm getting ready to do here, nothing's going to cancel in this problem, right? Nothing cancels. So this one is going to have no holes. There will be no holes in this problem. Okay? Where do vertical asymptotes come from, Declan?
For this one, it'd be the denominator section 3, so x cannot be 3 in this
The
case.
denominator cannot be 0. Remember, guys, you know that. Denominators cannot be 0. So, what makes this denominator 0? What x value would make that 0? 3. So you have a vertical asymptote at x equals 3. Now, this is kind of like your rule book. This tells you how to find all the important things you need to find. So if you're looking for a hole, you gotta be able to cancel something out. If you're looking for a vertical asymptote, you're looking at your denominator, and so on, right? This is our key. All right, so we've already found the asymptotes. That's old news. We learned how to do that before. Remember, we always make them dashed lines, and we always label that. And if you get confused about, okay, is it x equals or y equals, when you draw it, whatever axis it crosses is the letter. So see how this crosses the x-axis? So it's x equals. And this one is y equals. Okay? All right. Now, so this problem is going to have no holes. So I'll just make a note up here. No holes. But I need to find my intercepts. So remember, if you want your y-intercept, you let x be 0. So let's let x be 0 in our problem. If we let x be 0, what do we get? Negative 2/3, right? So 0, negative 2/3. There's my x, or excuse me, my y-intercept. My y-intercept. Now, I want to find my x-intercept, so I have to let y be 0. So I'll do the work right here. So 0 equals x plus 2 over x minus 3. Every problem we've done in this class, we've tried to get rid of our denominator when we had to solve an equation like this. So what happens if I multiply both sides by x minus 3? What happens? Isn't it still 0? So 0 equals x plus 2, which means my x-intercept is where? Negative 2 comma 0. Perfect. Now, I'm going to give you a little hint. Don't want to confuse anybody. But notice, where did my x-intercept ultimately come from? It ultimately came from the numerator. That will always be the case. So your x-intercept is where your numerator equals 0. If you want to remember that, great. If you don't, you'll work through this process and it will work every time. So, first thing I said to you today was, when you do these graphs, we're going to be looking for these 5 things. We have everything. So now I somehow have to draw my picture. Well, it all goes back to BFFs. Everything goes back to BFFs. You have a BFF. That's a fraction. That's a fraction. You have a BFF that looks like this, right? What's the name of that one? Who remembers? 1 over? That's your reciprocal function. Do you remember what it looks like? All these are going to be some form of that. Remember what this looks like? This is the one that has the asymptotes. And this.
Okay.
This is the same picture, but it's been shifted around. The asymptotes are no longer on the axis. Now the asymptotes are here. Well, these 2 points are on my picture, for sure. They're part of my picture. So I'm going to go ahead and draw kind of like a reciprocal function shape right there. This is my asymptote and this is my asymptote. Where do you think the rest of this picture is?
On the top right.
On the top right. Because they're always opposite each other. I shouldn't say always. There are random weird problems. For us, they'll always be opposite each other. And we're done. You just sketched your first rational function. Okay? Alright, well I'm gonna erase this now. Is everybody okay with that? We're gonna look at the next one. Alright, so here we go. What is it? X minus 2, 1 minus x. Alright, take a second. I know we've only done one, but a lot of this is review conversation. So while I'm putting the attendance in, take a second and see how many of these things you can get into the picture. on your own. Yep. You can look in the thing back there, in the bin on top of the stool. If not, you can do it in Notability. All right, Cadence here. Xavier, Jacob. Well, seems like no one's here, but I guess we're all here that are supposed to be, so that's good. All right, were you able to get anything in? Yeah, it'll be in, it'll be in Schoology. All right, so anybody get any of these? What did you get, Jacob?
The vertical asymptote's 1.
The vertical asymptote is x equals 1. Now, let's get in the habit of x equals and y equals, guys. Because if you just write 1, I don't know what you're talking about. I don't know if you mean this line or this line. So you've got to use the letter. Verticals are x equals 1. Perfect. Everybody clear on that? It's what makes the denominator 0. Declan?
Horizontal is y equals -1.
-1. This one's a little trickier, guys. Things aren't lined up very well. But when you compare the powers, do you see -1? Is this problem gonna have any holes? No. The only way you can have holes, kids, is if you factor and cancel out a parentheses, and that's not gonna happen here. You can't factor anything. So again, no holes. What about our intercepts? Well, the easiest one for me is just to put in zeros for the x's. This will be my y-intercept. So if I put in zeros for my x's, what do I get for y? If I put 0 in for x, -2. So 0, -2, there it is. Now, how did we say, what was the shortcut to getting our x-intercepts?
Numerator equal to 0.
Numerator equal to 0. What would make the numerator equal 0?
2.
2. So these are intercepts. So they're going on the axis, not on the asymptotes. They go on the axis. Now all our bases are covered. Now we have to draw the picture. Well, you know the general shape, right? It's going to be the reciprocal function shape. Can you see down here, because of that point right there, can you see a shape that looks like that? And because that point's right there, can you see a shape that looks like this? Remember, as you go sideways and up and down, your curve is going to follow along the asymptote. Okay, so it's kind of, the asymptote kind of frame it. You okay with that? Seems not too bad. Well, look at the next one, guys. We okay here? Do I need to, anybody have a question about this? Does that have to erase it? Okay, look at the next one. It's a little bit bigger problem. What do you think we might think about doing first? Yes, factor. And the reason we want to factor is factoring is the only way we'll know if we have any of these or not. Because in order to cancel, you have to factor first. So how does this thing factor?
Difference of squares,
Difference of squares
top and bottom.
over difference of squares.
Nothing cancels.
So I don't know if it's bad news or good news, but nothing cancels. So once again, we have no holes. All right, what do we have? Well, let's just start with what makes the denominator 0? What would make your denominator 0? 3 or negative 3? What does that mean? I have 2 vertical asymptotes. So I have a vertical asymptote at negative 3, and I have a vertical asymptote at positive 3. Now, most of you, I think, can look at this and say 3 and negative 3. But if you can't, just set it equal to 0. So if you set x minus 3 equal to 0, it says x equals 3. That's where your asymptote is. It's at 3. And the other one would be at negative 3 if you did the same thing. You can have lots of vertical asymptotes, depending on how much stuff you have in the denominator. But you will only ever have one horizontal. Okay? Look at the problem. I would go back to the original problem. What's my horizontal asymptote? No, my horizontal asymptote comes from boxing in the
Highest power is
highest power of
Yeah,
x,
x.
which is x squared. So I have x squared over x squared, which is,
1.
so my horizontal asymptote is again at y equals 1. And we have already determined we have no holes. So the only thing left is to find the intercepts. All right, where do they come from? Well, let's and I don't care where you go, sometimes it's easier to go back to the beginning. If you put zeros in here for x, you put 0 in here for x, so that's what we do, we put 0, and then x be 0. That's what we're doing, we're letting x be 0. What do we get? What's our y value?
4 nines.
4 nines. So, when you plot this, it's kind of important. You have an asymptote of 1. Is 4 nines higher than 1 or lower than 1?
Lower.
Lower, so 4 nines is gonna be like right here. Right, now I need my x-intercepts. Where do they come from? The x-intercepts come from letting the numerator be 0.
So negative 2.
Well, what makes the numerator be 0?
2 and positive
2 or negative 2? Kids, do not stare at me like you know what I'm talking about. You just took a test where you had to graph things, and if you had those 2 parentheses, where would your dots be on the x-axis? At 2 and negative 2, right? Same thing. So I've got a dot at negative 2 and a dot at 2. This is your x-axis. Now, because of the squares in the problem, this is going to be more than a reciprocal problem. It's going to have some of that in it, but guess what it's also going to have in it since it's a squared problem? What do squares look like? Parabolas. So guess what we've got right here in the middle of this picture? Because connect the dots, folks. Don't we have kind of a parabola right there? Now, what's the rest of the picture going to look like? Well, the rest is going to look like a reciprocal function. It's going to have a piece up here and a piece over here. Now, you trust me, because you know I would never lead you astray, at least not purposefully. Why is it like that? Couldn't it be down here? I mean, wouldn't that make a logical, I mean, wouldn't that be another option? Put this piece down here instead? Actually, no, for two reasons. First of all, if you tried to put this piece down here, what would it do right here?
Cross the x-axis.
Okay, wait a minute, and that would make it an x-intercept? But we already plotted those, right? No more, that's it. There are two x-intercepts, no more. Another thing is, and I'm trying not to give you too much stuff all at once, but another thing is, when you have an asymptote like this, if you know that this side is going down, then this side is automatically going to be going up. That's the way they work, okay? Again, unless it's some weird situation, which we're not doing, if the left side is going down, the right side will be going up. If the right side is going down, the left side will be going up on vertical asymptotes. Okay, that was a doozy. Before I erase it, last chance to ask anything, Abby?
No, sorry, it's supposed to be safe.
Okay. We good? All right, let's look at the next one. Okay, take a clue from the last one we did. What do you think is going to be our first step? We're going to factor. Okay. So somebody tell me how the top factors.
X minus 5x plus 1.
X minus 5, x plus 1. I think he's right. How do we check? Some of you aren't very good factorers, so if you're one of those people that misses a lot of your factoring problems, FOIL it back out. Remember that this times this has to be -5. That's the rule. And then this and this have to add up to -4. That's the rule. That's how we factor. All right, how about the bottom?
2 times x plus 2 times x minus 2.
Well, it's 2 x squared minus 4. That would be our first step. Take out the GCF. And then what about x squared minus 4?
X plus 2 x
The
minus 2.
difference is squared. So x minus 2, x plus 2. So this is my factored problem. And once again, what do you notice? No holes. I thought we were gonna get some, but nope, no holes for this problem either. Because the only way to get holes is if something cancels. Now, you know eventually we're gonna get a problem that when we factor it, something's gonna cancel out, right? But it's not this one. All right, here we go. Somebody besides Declan, I love you, Declan. But somebody besides Declan, give me something important. These are the important things in this picture.
Denominator equals 0.
So what would that be, Olivia, if the denominator has to be 0?
2, -2.
Yep. Now, that doesn't have an x, so he's not gonna be an asymptote. It's like what we did in the last unit. Whatever has an x gets a dot. Well, whatever has an x gets an asymptote. So, -2 and 2. Good. Now Olivia, you're quiet. Somebody else is gonna pitch in another something here from the list. Jacob?
X-intercepts.
All right, where are my x-intercepts?
Those
Where
would
are
be
they coming from, folks?
Numerator equal to 0.
Yep, so where are they?
5 and -1.
At 5 and -1. Oh, this one's gonna look different. This one's gonna be wild and crazy. We hit the big time, folks. Let's see, let's keep going. What else? Somebody else. Give me something. Xavier, where's my horizontal asymptote? You remember how to find it? Has to do with a box. Well, that's your original problem, Xavier. Okay? Now, the highest power in the problem is x squared. Would you agree with that? So box them in. The x squareds will cancel out if you only look at the box. The x squareds will cancel out, leaving you with what? Well, 2 in the bottom, but 1 in the top. Isn't that a 1x squared? So that's going to be 1/2. So my horizontal asymptote is y equals 1/2. We've got our asymptotes. We don't have any holes. We have our x-intercept. What's the only thing left to find? The y-intercept. And how do we find a y-intercept? We let x be 0. So if I go back, and you can put it anywhere you want. I usually go back to the original, because if I put in a 0, aren't all of these gone? If x is 0, they're like gone. So all I have left is -5 over -8, which is 5/8. Right? The graph is important. This is 1/2. Is 5/8 more than 1/2 or less than 1/2? More, so it's gonna go right here. Okay, this picture's very strange. Remember, you can't cross a vertical asymptote. So these are like walls, brick walls. Can't pass them, can't cross them. So in the middle here, in between these two walls, I have these 2 points. Any idea what's going on in there? I know what I'd be thinking if I were you. I'd be thinking parabola. Well, what's wrong with that?
Can't cross the asymptote.
Can't cross the x-axis again. So if these 2 points are connected, which they are, where does this have to go? Where do I go from here? I can't go down, so I'm gonna have to go up. So what shape do I have in there this time?
Cubed.
It's very hard to explain, but it's kind of a cubing shape. The cubing shape is also what we call the tangent curve. We'll study that more in chapter 4. So you have kind of a tangent looking shape in there. Again, what I need you to understand, and this is a hard problem, I need you to understand, that as soon as you tell me my x-intercepts are here and here, and they came from the numerator, you cannot cross the x-axis any other place. So while my gut was saying to me, okay, let's have a little parabola action here, it couldn't be that because it can't cross. So if it can't come back down, then it has to go up. Now, again, if I were you, I'd be a little bit nervous about what happened right here. What did I do right here?
Cross, yeah.
I crossed a horizontal asymptote. They are crossable. Verticals are not. You will never cross, ever, 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 in any picture, everywhere, anywhere, you will not cross a vertical asymptote. But you can cross horizontals. Alright, now, I want you to think about the fact that this point is sitting out here. And it's part of the picture. What do you think's going on over here in this corner? Don't you think it has that typical reciprocal shape? And look, guys, see how this goes up? Remember what I said? If it goes up on the left side, it's gonna go down on the right side of this asymptote. Okay, so with that in mind, what do you think's happening over here? It's over here. Yeah, it's right there. Because it's going down on this side, so it has to go up on that side. That's a tough problem. That's a toughie. We don't mess around. Reversity. You ready for the next one? Alrighty. Okay. Hayden, how do you think we will start?
We box in the highest power.
Okay. We haven't been starting that way, but we certainly can. That's absolutely fine. And if I do box in the highest power of the variable, what am I looking for? What is that going to tell me?
The horizontal axis.
It is. Now, what is the highest power of the variable? In the whole problem, what's the highest power? X squared. Wait a minute. How many x squareds are on the top?
No.
0. So remember doing this before, kids? You have to write in a 0. So when you box it, you see that your asymptote is at 0 over 1. What is 0 over 1? 0. So my horizontal asymptote is actually at y equals 0. Okay. That's all right. We can do that. Melissa, what do you think we might do next? Factor. Now, the top doesn't factor. So if that 0 is bugging you, you can go ahead and erase it now. We don't need it anymore. The top doesn't factor, but the bottom does. And Melissa, how does the bottom factor?
X minus 3x plus 1.
Beautiful. What?
No holes.
No holes. So we're gonna have no holes again. I know you're dying to get one. We're gonna get one here in a second. Not this time now. What do we have though? We have a horizontal asymptote already in the picture. What else do we have?
2 vertical asymptotes.
2 verticals. And where are the verticals?
3 and negative 1.
3 and negative 1. Now we need our intercepts. So look at our little thing here. How do you get x-intercepts? You get x-intercepts by making the numerator 0. So what would make the numerator 0? -5. And how do you get a y-intercept? You plug 0 in for x. And you can do that anywhere you want. You can do it in the original, or you can do it at the factored one. Again, I like to do it in the original because every time I put in a 0, that goes away. So all I have left is negative 5/3, right? So. Another hard problem. Now you gotta figure out what's happening. Anybody have any ideas at all? Keep in mind that you have a left side of the picture, you have a middle part, and you have a right part of the picture. Anybody have any idea about any of those parts? Declan?
Do we go reciprocal shape on the left to hit -5?
I would, but what I need to figure out is it gonna be one going like this or one going like this? So I might do the middle first, because in the middle, I got a point, right? I got a point. I'm pretty sure this is going down. Can this one go up? You know how that tangent shape or cubic shape before? Can this one go up?
No,
No, why not?
it doesn't cross there.
It can't cross the x-axis. Kids, when I have you put the x-intercepts on there, I do it for a reason. That's where you cross the axis. So this is the only place you can touch the x-axis. So wait a minute, this point's here. What about, it's gotta be some kind of a parabola. I'm not sure exactly, but it's something that goes down. Now, Declan's question was, or his statement was, this is gonna be some kind of a reciprocal shape. You were just trying to figure out whether it was up here or down here. Well, now we know, because since this one's going down, this one has to be going up, doesn't it? And since this one's going down, this one has to be going up. This problem is a tough one. I would never give you this hard of a problem on a test or quiz. But it doesn't just start here. It actually keeps going and following out that way like that. But you wouldn't know that without some more practice, but that's what it does. Okay, we're gonna do 2 more, and then I'm going to be quiet. Does anybody have a question about this one before I erase it, Jacob?
Oh, I'm sorry.
Okay, here we go. Guess what's gonna happen?
Oh.
I think so. Let's check it out. How will we know? What will we do first on this problem?
Factor.
We will factor it. How does the top factor? X minus 4, x plus 1. Is it important that we get the factors right? Your picture will be completely wrong if you factor wrong. So if you are a little tentative on your factoring, don't hesitate to FOIL it out and make sure you're right. Now that is right, but FOIL it out and make sure before you go on. I think the bottom you can probably do. What's the bottom?
Plus 1,
X plus 1, x minus 1. So now we've got it. So now this cancels out. And what we are left with is y equals x minus 4 over x minus 1. Would everyone agree with that? So I'm going to put a box around that problem, or put a star next to it or something, because that's what I'm graphing now. I'm not graphing this anymore. Now I'm graphing this. However, because I cancel, I am going to have a hole. And the hole is a point, x comma y, and it comes from what you canceled out. So what x value, these are x's, what x value did I cancel out? It's in a parentheses, negative 1, negative 1. Wouldn't that give me negative 1? Think about plotting it somewhere. Wouldn't it be negative 1? So my x coordinate is negative 1. When we take numbers out of parentheses, don't we always change them? That hasn't changed ever. We always do it. So it's negative 1. How do you suppose I'll get the y coordinate? The x coordinate came straight from what I canceled. How do I get the y? Plug in negative 1 right here. So I know x is negative 1. How do I find y? I plug it in. So I'm going to plug in negative 1, but it's important that you don't go back there. That is crossed out. We plug it in right here. So we have negative 1 minus 4 over negative 1 minus 1. So negative 1 minus 4, negative 5, negative 1 minus 1, negative 2. The negatives cancel. So my whole is at negative 1 comma 5 halves. So negative 1 comma 2 and a half, basically. So when I graph it, it's a nice little open dot. A hole in the picture. Now, the rest of what we're doing, go ahead, we try something in now. The rest of what we're, get that thing out of your ear. Get that thing out of your ear.
Oh, my bad.
Yeah, you're very bad. Get it out. Okay, now the rest of the stuff we're looking for is going to come from right here. Okay, this is where we're looking. So tell me, what else do I have in this problem? Where's my vertical asymptote? At 1, x equals 1. Vertical asymptotes come from the denominator. This weekend, your job is to refresh yourselves on these things. Where's my horizontal asymptote? Y equals 1. I can't remember who it is, but somebody on the last problem found the horizontal asymptote first. If we had done that first, if we find our horizontal asymptote first, would it still be y equals 1? Yeah, because it'd be x squared over x squared. Okay. What makes the numerator 0? That's my x-intercept. What makes the numerator 0? 4. And what happens if I let x be 0? If I let x be 0, remember this is where I'm doing it. If I let x be 0, what do I get? I get negative 4 over negative 1, which is 4 again. Now, look at what's on your paper. Can you connect the dots? What do you think this shape is going to look like? What do you think is happening over here? It's a reciprocal, isn't it, guys? Isn't that what you got over there? And what about over here? You got a point right there. Isn't the same thing happening over here? So that hole in it, but the hole actually made it easier. Because the hole took out an asymptote, basically. Alright? We got 9 minutes to do the last problem. I want you to see how far you can get on your own. Alright, the last problem in this section. Let's see how far you can get on your own. You all know you need to factor. And some of you are gonna struggle, because there's a 2 out there. But you know what? If you just take your time, you can figure it out. What times what gives me 3? 1 and 3. So I'm just gonna try one number, 1 there and a 3 there. Now, because it's a -3, doesn't something have to be negative? So maybe I'll say +1 -3. I'm guessing. That's what we do, we guess. Now I'm gonna check it. So I'm gonna FOIL this. I get 2x squared minus 6x plus x minus 3. Does that give me what I thought it would? Why are you shaking your head? You guys, what's -6 and +1?
-5.
-5. That's exactly what I want. So those are my factors. Remember how in the last unit, we had to guess a number, we divided it in, and if it gave us 0, we were so happy. But if it didn't give us 0, what did we do? Try it again. So if this doesn't work out for me, I'm gonna try again. What goes in the bottom? -3 minus 1. So there we go. We're gonna have a hole in our problem. We have 2x plus 1 over x minus 1. That's what's left. Where is the hole going to be this time? Look at what canceled. What is your x? 3. Thank you, Olivia. 3. And how will we find the y? 3, because that's what canceled. How will we find the y? Plug in 3 right here. So I'm going to get 2 times 3 plus 1, 7. Over 3 minus 1, 2. So 3 comma 7 halves. Or 3 1/2. Yeah. Tell me what else I got.
Horizontal asymptote of 2.
2 you say? Horizontal asymptote of 2. How did you do that?
2 divided by 1.
Box them, right? Okay, what else do we have? At 1, very good, x equals 1, perfect. Because vertical asymptotes come where the denominator is 0, right? Do I have an x-intercept in this problem? Well, where do they come from? How do you get x-intercepts? So take your numerator and set it equal to 0. Now our other problems, we could do that in our head, but when you start putting 2's in there, it might be confusing. So 2x equals -1, so it looks like it's going to be -1/2. And then where's my y-intercept? My intercept, I'm gonna let x be 0. So it's just gonna be a negative 1. Based on that, you guys, you should be able to draw the picture. What do you think it's gonna look like?
Reciprocal.
Reciprocal over here. Right? What about over there?
Reciprocal.
Same thing, but in the opposite quadrant. As long as there's only one vertical asymptote, that's the shape we're gonna get. You know, this and that, or this and that, and they can be opposite corners. It's when you start putting two vertical asymptotes in that things get a little bit off. Okay, so I wanted you to know, so we just finished 2-6. So that homework will be due on Tuesday. Next time we have class, which I don't know when that is, I'm gonna give you a more than one practice quiz. We're gonna work through that, the graph. We'll work through those, and then the class after that, we'll have a graphing quiz. One problem, and you do this. Okay, so we just did the whole lesson. You're going to do your homework. You're gonna come in on Monday morning if you need help with it. Then we're gonna practice in our next class, and then we'll quiz in the one after that. Are we clear on that? All right.